Hello students, welcome back. So now we are going to be focusing our attention on box plot. Your box plot, it looks something like this right here. So box plot, this another name for that is a box and whisker plot. And it basically summarizes the distribution of your numerical data. This is important, only numerical data, and it uses five key statistics. The first one is minimum, first quartile, median, third quartile, and maximum. Your minimum would be this one right here. So you can tell that your minimum actually value would be, I would say, like from 5 maybe, or 2 or 3 can go, this number can go up to like 51, 52, or 53. So it kind of gives you minimum and also maximum. Also tells you the first quartile. Your first quartile refers to that 25% of your point are going to be below your first quartile point. So your first quartile point is this one, the first one. So whatever this number is, let's say this would be, I would say 14. So that means 25% of your data for this particular case is less than 14. Then if you have median right here, in this case median is 50%. So that tells you, by the way, this would be your median, this line right here. So that tells me that 50% of my data is below, I would say 18. It seems like 18 over here. And likewise, there's a third quartile that would be this point right here. So that tells me that 75% of my data is below 24, I would say 24. Okay, and then also it also tells you middle 50% of your data, it lies inside the box. Well, this one is 25%, this one is 75%. So in between, that's your 50%. So that tells you that 50% of your data, it lies between this number and this number. This would be 14 to maybe like 24. Okay, so why do we need box plot? Well, it shows distribution at a quick glance. So just by looking at your data, you can tell where your data is centered, how spread your data is, and is it skewed or not. For example, just by looking at this, you can tell that most of your data is between this and this area right here. So also, you can identify outliers very clearly. Just by looking at this, you will see these circles that actually lies outside the range of this whisker and this whisker, they will be outliers. So by looking at these small circles over here, generally they tend to be outliers. So it's able to identify that, and visually you can see that. They're excellent for comparison. So maybe you want to compare distribution across categories. So this is much better than histogram when you compare groups, and I'll show you like how we compare distribution through different categories. Also, it helps you find the median line Q2. So Q2, that would be this one right here. This is your median line. Now, if your median line, it is not centered, that will indicate that your data is skewed. And I'll show you later on in this session an example of that. So first thing I'm doing is importing my Seaborn library and also importing my matplotlib library. I'm setting my fig size to 8 comma 4, and in this instance I'll be studying tips dataset. So I'm loading the tips dataset that is part of your Seaborn library, and let's print out the first 10 samples just to see what's in it. So it has total bill, tip, sex, smoker, date, time, size of in this dataset. So in this case, let's do a box plot. I just say sns.boxplot and specify your data. So in this case, my data equal to tips, and specify your column. My column is total bill. That would be this, right? So people go to restaurant and they pay a total bill. I would just want to know what is the spread of the total bill. When I plot this, this is how this is what it shows me. So I can tell that people, most of the data is spread between this number and this number. So you can make some few observations. For example, your first quartile, which is 13 approximately, just by looking at this, is 13 approximately. So that means 25% of the total bill data is less than 13. Your Q2 is 17 approximately. This is your Q2 right there. So this comes out to be, I would say, 17. That means 50% of the total bill data is below 17. And likewise, your Q3, that will be 24. This will be Q3 right there. So that will be 24. That means 75% of the people, their total bill was less than 24. 50% of your customers, they paid a total bill between 13 and 24. In other words, between Q1 and Q3. So 50% of your data lies between this value right here. So by looking at this, you can tell that 50% of customer paid this bill. That would be 13 would be over here, and 24 would be over here. Okay, a few customers, they are your outliers. They paid a high total bill. There was more than 40, and you can see that your 40 is right here, and all these dots right here, they indicate your outlier point. So these people, they paid like an unusually high total bill. Most of the people, they paid their bill in this range. There were few people over here, few over here, but these guys were paid really high much. Okay, in this case, median Q2 is not in the center. So that tells me your data is skewed. So if you look at this right here, this line is not exactly in the center. It's a little bit on this side. So that tells me that if I plot a KD curve of this, it's going to be a little bit skewed. We can also do vertical box plot, by the way. So in this case, you just say y equal to total bill. Before, I did x equal to total bill, and if you specify y equal to total bill, and when you run this, it's going to give you vertical plot. And now let's do numeric value categorized. So in this case, I'll plot a box plot of the total bill with category by size. Size refers to the number of people who came in the restaurant, whether 2, 3, 4, 5, 6, depending on how many people came in the restaurant for that group. So in this case, data equal to tips, x equal to size. So in this case, my x, make sure this is category. So this way, your x-axis would be your categorical data, and your y is total bill. So this is numeric. So when I run this, this is what I get. So over here, you can see that this is size 1, size 2, size 3, size 4, size 6. And then these are the total bill right here. So just by looking at this, you can make few observation that as the size goes up, size like you go from 1 to 2, 3, 4, 5, 6, your range of total bill is going up. You can see that people are basically range of the total bill is going up. That makes sense. Like if you have a smaller group of people, they're gonna pay less total bill. But if you have a large group of people, let's say there are 6 people in the group, they're gonna have a high total bill. So that kind of makes sense. And then you can see there are some outliers for size 2 and size 3, and there is some outlier for size 5, but rest of them they do not have outliers. Let's make some more. So in this case, let's do box plot of tip categorized by day now. So in this case, my x equal to day and my y equal to tip. So I just want to do tip versus day. And so this gives me the tip versus day. You can see Thursday, Friday, Saturday, Sunday. And so there are some outliers on Saturday. There were some people who actually gave some high tip. Thursday, again, there were 2 people who gave extra tip or high tip. So what it tells me is that of 50% of the customers on Thursday, they paid a tip between 2 and 3.6 approximately. You can see that on Thursday, that is this right here. So 50% of the customer, they paid a tip between this number and this number. That would be between 2 and 3.6. I'm just 3.6, I'm just guessing, by the way. It could be 3.7, 3.8, could be any number, but it kind of gives you an idea. uh, 50% of the customers on Sunday, they paid a tip amount between 2 and 4.1. Let's go verify that. You can come and take a look. You can see that on Sunday, 50% of the customers, they paid a tip between 2 and this number. So this is where your 50% of your data lies. Okay, on Thursday and Saturday, few customers paid higher tips. There were outliers. We saw that on Saturday and on Thursday. So there are some outliers. And it seems like there's a more tip on Sunday. But let's go verify. Yeah, you can see that. You see the box is like a little bit more wider. And also the range is a little bit higher for Sunday. So that tells me that on Sunday, people paid more tips. And now let's add sex to this. So my x equal to day, this is my categorical, y equal to tip, this is my numeric, and in this case, I'm specifying my u equal to sex. In other words, the gender. So when I plot this, you can see that it separates based on the gender, male and female. So you have, before this, it was basically Thursday, Friday. If you remember, all Thursday were taken together. Now I'm separating Thursday from males and females. So basically, there are 2 categories now. So on Thursday, you have this. This would be your male, this is your female. On Friday, male, female. Saturday, male, female, and so on and so forth. So you can make some observation over here. Like, for example, males are paying higher tips than females. Well, let's see. Well, you can see that the range, like this box, is higher over here. It's higher, it's higher, it's higher. So the male box, okay, male box plot, it tends to have a high range. So that tells me that the males are paying higher tips than females. Let's do fill equal to false right here. So in this case, I'm saying fill equal to false. Basically the same thing as the one on top, but by specifying fill equal to false, it's not gonna fill the box. So now this gives you a little different visual. By the way, you can draw the same conclusion as you did before, but kind of this one, the only difference is it does not fill up the box with the colors for you. And now let's see the total bill categorized by time. So in this case, my x equal to day, my y equal to total bill, and my u equal to time right here. So if you remember time, there are 2 kinds. There's a lunch time and there's a dinner time. So in this case, this is my total bill, and these are my days and categorized by lunch and dinner. So on Thursday, oh, that's interesting. It seems like on Thursday, a lot of people they came for the lunch, but pretty much nobody comes for the dinner. And oh, look at that. On Saturday, Sunday, it seems like only dinner time. There is no lunch for Saturday, Sunday. So you can draw these types of conclusions. So for example, on Friday, people came for both lunch and dinner. You saw that over here. And on Friday, total bill is higher for dinner than for the lunch. So you can see that your total bill is a lot higher than this one and a lot less than this one. That would be higher for dinner and smaller for lunch. Then not many people came for dinner on Thursday. We saw that dinner is pretty much like empty. And then on Saturday and Sunday, people came for dinner mainly. And actually, not only mainly, but actually they all came only for dinner. There's nobody else over here except only for lunch. And now let's try to understand skewed data set. So I'm picking up Thursday data set. In this case, I'm filtering all the Thursday, and you can see that when I print out Thursday tips right here, it prints out Thursday, Thursday, Thursday. All of the data set is only for Thursday. So let's do the histogram with KDE only for this data set right here. So I'm specifying my data Thursday tips, and my X column would be tip column. So when I plot this, you can see that it is skewed. So your data is going like this, and then it's going like this right here. So it's skewed towards the right hand side. Now let's do a box plot of the same data set right here. So data equal to Thursday tips, X equal to tip, and now do this thing, and this is how it looks like. You can see that your median is no longer in the center. That's one of the characteristics of your skewed data set. Also, you notice this line, this whisker, or this side of the whisker is longer than this side of the whisker. So this is another characteristics of your skewed data. So in this case, median is shifted towards the left. The right whisker line is longer than your left whisker line. So this is the characteristics of your right skewed data. For left skewed data, it will be the other way around.